Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on exponents and logarithms. Today, we will solve simple logarithmic equations and identify the characteristics and mantissa of a given logarithm. If you are ready, students, we will begin. You have already learned the nature of exponents. The equation 3 times 3 times 3 times 3 can be shortened to the exponent 3 to the power of 4. We can think of logarithms as being the inverse of exponents. For example, we know that 4 squared equals 16. In this case, the base is 4 and the exponent is 2. We can write the same equation in logarithm form as the logarithm of 16 to the base 4 equals 2. In general, for a fixed positive number b that does not equal 1, and for each a that is greater than 0, b to the power of c equals a if and only if c equals the logarithm of a to the base b. Every logarithmic statement can be translated into an exponential statement and vice versa. Essentially, the logarithm of a to base b is the answer to the question, to what power must b be raised to produce a? Students, let us take a moment to explore these properties. Here are 3 basic logarithms. Solve each one and I'll be right back.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am confident that you had no trouble solving each logarithm. 4 times 4 times 4 equals 64. This can also be expressed as 4 to the power of 3. Therefore, the logarithm of 64 to base 4 is 3. 5 times 5 times 5 times 5 equals 625. This is expressed as 5 to the power of 4. Therefore, the logarithm of 625 to base 5 is 4. The third logarithm is different. As you can see, 81 divided by 9 equals 9. This is expressed as 81 to the power of 1/2. Therefore, the logarithm of 9 to base 81 is 1/2. If you solve these logarithms on your own, you're doing very well. Our decimal system is based on numbers of the form 10 to the power of n. The number 1 is 10 to the power of 0. 10 is 10 to the power of 1. 100 is 10 to the power of 2, and so on. 0.1 is 10 to the power of -1. 0.01 is 10 to the power of -2. 0.001 is 10 to the power of -3. I am sure that you see the pattern. All positive numbers can be written in the form of 10 to the power of n. The logarithm of a positive number to the base 10 is called a common logarithm. One important use for common logarithms is simplifying numerical computations. While they are not as widespread as they once were because of electronic calculators, certain operations like 5 to the power of 1.27 can be performed using common logarithms. A common logarithm is usually written without indicating its base. So if a logarithm is given with no base, we take it to be base 10. Students, let us do another activity. Please find the common logarithm of 321. Remember that you have a table of logarithmic values at the end of your textbook.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. The logarithm of 321 is equal to the sum of the logarithms of 3.21 and 10 to the power of 2. This is because of the logarithmic rule that states that the logarithm of xy to base b is equal to the sum of the logarithm of x to base b and the logarithm of y to the base b. Therefore, the equation is equal to 2 plus the logarithm of 3.21. The common logarithm of a number between 1 and 10 is a number between 0 and 1. When we check our table, we find that the approximate value of the logarithm of 3.21 is 0.5065. Therefore, the logarithm of 321 is the sum of 2 and 0.5065. This example can be written in this fashion. If we write a number x as x equals m times 10 to the power of c, when m is greater than or equal to 0 but less than 1, then x can be read from our logarithm table. The logarithm of m is called the mantissa, and c is called the characteristic. Therefore, the common logarithm of a number is equal to its mantissa plus characteristics. Now, suppose that we have an expression like this. The logarithm of x is equal to 0.354. Students, what is the value of x?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Did you find x? We must apply the anti-logarithm of the logarithm of x. In this case, it is equal to the anti-logarithm of the logarithm of 0.354. After we search our table for 0.354, we find it where row 2.2 meets column 6. Therefore, x equals 2.26. Great work, everyone. That is all for today's lesson. Until next time, thank you, teacher. Thank you, students.